All right, let's find all 6 trig function values for an angle t on the unit circle that's 5 pi over 6. Now, if you know me, I'm not just going to put a unit circle up here and just go straight to wherever this angle is. I'm gonna break this thing down a little bit. Okay, try and make you guys problem solvers and not just robots. So first of all, if it's labeled as 5 pi over 6, that means its reference angle is pi over 6. Okay. If it can't be reduced, then this can't be reduced. So that means this 5 pi over 6 angle, if you aren't comfortable with the unit circle yet, it's in your best interest to get there. But pi over 6 reference angles are 30-degree angles, right? Okay, so 5 pi over 6 is one of these 4 angles that I've drawn here. All right, and this is just, again, could I just look at a unit circle and get the coordinates? Yes, I could. Okay, I'm very well steeped, and when I say I'm meaning you should be very well steeped in the first quadrant of the unit circle. And pi over 6, this 30-degree reference angle here, I know that the coordinates of that point are radical 3 over 2 and 1/2, which means any one of these pi over 6 angles has coordinates just like that, only some of them are negative. Okay, the question is, which one of these angles is 5 pi over 6? Well, I know that this angle is pi, right? 180 degrees or pi, and that would be 6 pi over 6. So if this angle is 6 pi over 6, 5 pi over 6, my number sense tells me, is less than that. So this angle is our 5 pi over 6 angle, right? So what we're talking about, I can get rid of some of the rest of this stuff now, okay? That's just using reference angles, using the symmetry of the unit circle. I'm even gonna, well, I guess I'll just leave that there. But so that means that the coordinates of this point are also radical 3 over 2 and 1/2. The question is, some of these, both have to be negative, right? Because we're in quadrant 2, where this is the origin. If I have to move to the left to get to this point, I know the x coordinate is negative, and if I move up, I know the y coordinate is positive. Okay, so this is a think aloud or a walkthrough of how I could get the coordinates of 5 pi over 6 if I didn't have a unit circle in front of me, using reference angles, using measurements that I know from quadrant 1. And if you've seen any of my previous videos, you know how important quadrant 1 is to understanding the unit circle. And then we use the bow tie and the butterfly effect to get to here. So the rest of this is cake, right? The sine value of any angle on the unit circle is its y coordinate. The cosecant of that angle is this flipped over, which is 2 over 1, and that's 2. The cosine of any angle on the unit circle is its x coordinate, and the secant of that is its reciprocal, which when I flip this bad boy over, we're not allowed to have that radical 3 in the bottom, so we're going to have to rationalize that out. So we end up with -2 radical 3 over 3 for our value of secant. Put a box around that one. And then the tangent of t is the y coordinate over the x coordinate, also known as sine t over cosine t, however you want to write it. So if I do 1/2 over negative radical 3 over 2, I've said in a previous video, tangent takes more work, okay? This becomes 1/2 times -2 over radical 3, which when we multiply these fractions, we can still cross cancel the 2's that are on this diagonal. We'll have 1 over radical 3. So as it currently stands, and I'm saying this now, as it currently stands, tangent of t is this. But not allowed to have the radical down here. So I'm going to multiply by radical 3 on the top and bottom, and I'm going to end up with radical 3 over 3. So here's my tangent value. Cotangent of t, right, is the reciprocal of tangent. It's x over y. Now I can go through this entire process all over again, right? But you know, when we talk about tangent, originally tangent looked like this, right? I could take that, I could flip it over, and then I could go through this process all over again, okay, and get something, and then get something else. Or when I said just recently, about a minute ago, that this was the current value of tangent. So tangent was this, It simplified to that, but its final value after all simplification was here. So the reason I put boxes around all three of these is because each one of those is a representation of tangent. Cotangent is the reciprocal of tangent. Which of these three boxed values, when I flip it over, is going to give me the cleanest, simplest representation, right? It's this one right here. Because when I flip that one over, it's going to be negative radical 3 over 1, which is just negative radical 3. So it actually ended up, that's why I stopped there and said, this is the current representation of tangent. Any one of those three can be flipped over to get cotangent, okay? I'm using the one that gets me the cleanest, simplest answer, all right? That's a good place to stop.